All right, this is start of a whole new chapter, huh? Section 5.0a. Interesting section number, but I guess that all that really matters, is the title, and the topic is scatter plots. I think in this lesson it's going to be just kind of the basics of a scatter plot. What is there to say? There's two variables involved, two real-life sort of things that are you can call them variables. So this example, to kind of start off the notes, relates the number of hours studied with the test score that you end up getting, say, on just like a random biology test or a history test or something. And a scatter plot involves different data points where, just as this first example, 1, 50, we're going to plot the data. And again, still kind of like x, y. So x, which here is now technically the number of hours studied, but x is 1, and then the y coordinate, or the test score, is 50, but 1, 50. Okay, and so that, for example, would be, well, apparently there was a person, so each one of these points, each one of these ordered pairs, represents like a certain instance of a person taking a test after studying for whatever number of hours. So this point represents a person that apparently studied 1 hour and got a test score of 50, like 50% or perhaps, okay? And then so this data point at 2, let's just do our best here. Where's 52? Whatever, I guess it's right about there. Just try your best. So apparently this dot represents a student in this survey that studied for 2 hours and ended up getting a 52 on the test. And then 371, about right there, good enough. Let's not forget about these, 1.5, so 1.5 is like right there. 55, so that point would be about right there. 2.5 on the x-axis is about right there, and then we go up to like 68, which, whatever, right there, good enough. 3.5, also a 68, right? This was 3.5, 68. There, good enough. 4, exactly 4 hours, goes with a score of 85. So there was a person that studied for 4 hours and got an 85. 4.5, 88. Whatever, good enough. 5.5, 93. I don't know, right there, whatever. 5, 95. And then 5, 95, 5.5, okay, and then 6, 100. So, you can see why something like this would be called a scatter plot, because these points, it looks like a bunch of scattered points. It looks like they're sort of making a line, but they're not all falling on the same perfect line. They're not, I guess the word in geometry is collinear. All these points are certainly not all collinear, but it seems like they're doing their best to kind of make a line, so it seems like there's some kind of relationship, there's some kind of trend here, some kind of mathematical thing going on with the number of hours studied and the test scores. This is called a positive correlation. It's easy to remember because it's kind of doing this positive uphill thing, like a positive slope kind of a thing. And but really what it means is when there's a positive correlation between two things, like number of hours studied and your test grade, it means when the hours go up, the test grade also goes up. And also likewise, if the hours go down, then your test grade probably goes down. Now, I know you might be thinking like, well, that's not necessarily true. You know, couldn't someone not study at all and get like a 100? So don't put this point on here just for the sake of our good notes, but couldn't there also been like this person right here, we'll just call him, oh, I don't know, Mr. J.Falk, that, you know, if it was like a math test in high school, studied 0 hours but got in 100, you know, and it doesn't need to take, you know, it doesn't need to be me. I'm sure there's plenty of you in class that often study for 0 hours and get a 100, you know, or there could be someone that studied their face off. They studied for a total of 7 hours and they only ended up getting like a 75. So like this could be a person, you know. So this line that all the dots that we plotted, you know, are kind of making a line. I mean, again, trying to get to the point here, no pun intended. But I think you would agree that even though there's not necessarily all people would kind of fall into this line-looking trend, I think you would agree that, well, I mean, I guess if I named a certain kind of test, like maybe this isn't the greatest example for like a high school math test or like a junior high history test or something like that. But I'm sure, like, you know, like let's say it was a test that was more like at a college level, or maybe some big cumulative like final exam, or, you know, the bar exam for, I don't know, is that for becoming a lawyer or something, or like you're taking some big final test of like medical school or something, or like some praxis exam in college. I would say like you would definitely more likely have like a good positive correlation bunch of dots where like, hey, if someone only studies for 1 hour when it's that big of a test, like that tough of a test, you're probably, you know, getting a very low test grade. But someone that's studied for many, many hours is getting a higher test grade. So anyway, to kind of move on with this lesson, right here, this next part of our notes, yep, positive correlation is only one type of correlation, right? Whereas variable A, you know, increases, the other variable also increases. And when one variable decreases, the other variable decreases, okay? So we already had this example of like, and again, I know it might not seem like the best example of like number of hours studied and the score you get on a test. So here's another one. Let's say the number of overall minutes played, like in a basketball game. Number of overall minutes played. What do you think would go along with it and have like a positive correlation with the number of overall minutes played? Maybe the number of total points scored, you know? So, I mean, you could, like, so basically if we plotted that, every dot would either represent a different player, you know, that in a particular match or game, or I guess maybe each point would represent a different game. Like maybe the whole scatter plot would be for like the same person, and then like each point would represent like a specific different, you know, game in a season or in their life. We also have a negative correlation. And yeah, you might already have some experience and you might have been expecting this, that when your dots kind of make a line, your scattered points are, you know, and again, you could have other points like randomly over here in this corner or up in this corner, But as long as, like, most of the points are making this downhill line, you can say that there's a negative correlation between variable A and variable B. Now, with a negative correlation, when one variable increases, let's say as variable A increases, the other variable is actually decreasing. And if the one variable decreases, then the other variable increases. So that's what a negative correlation is really all about. So I don't know if this is the greatest example, but the example I have in the notes here is yearly salary versus the amount of debt that you have. Like, the amount of debt is money you owe. Like, let's say you borrowed money to buy your house or buy a car, or you have like student loan debt from college or medical, I don't know, right? So it's not the greatest example, you know what I mean? Like, I'm sure there could be points all over the place, but I don't know. Overall, don't you think you agree that the more someone makes, right? Like the more your salary is, the less debt you probably have. You know what I mean? Like, I think most of the points would sort of follow this downhill trend. You know what I mean? The richer you are, the less you're going to be in debt, right? And the less money you make, it doesn't automatically mean that you have like a lot of debt, but I don't know. So again, not the greatest example, but so just try to focus on how if it's a negative correlation, that means when one variable goes up, another variable goes down. I might be spoiling a future homework problem or something, but I think one of the better examples is like your speed, like your average speed on a trip versus the total time it took for you to make your trip. So like the faster you drive to Florida, all right, the less time it's going to take, and the slower, if your driving speed overall goes down, then your overall time goes up. You know what I mean? Even though that might make a perfectly straight line, not a scattered bunch of dots, but anyway, you get the idea. But then we also have like no correlation. Two variables could have a positive relationship between them. They could have a negative relationship between them. Or there could be just no relationship at all. So when one variable increases, the other variable, it's there again, there is no connection, And again, I'm not in love with this example I have in the notes, but whether the temperature goes up, or whether we have a high temperature or a low temperature over maybe on this axis, toothpaste sales, I don't think there's any solid like uphill, like if you plotted a bunch of points, like, hey, on this day the temperature was 40 degrees. What was toothpaste sales? On this other day the temperature was 58 degrees. And then what was the toothpaste sales? So every dot might be like for a different day or something. But actually this graph, you could argue might be like kind of flat, like almost like horizontal. Like no matter what the temperature is outside, for the most part, unless it's like way too cold to even go outside to buy toothpaste. But I would think for the most part, most of the points that would get plotted would just about form a horizontal line, right? Most temperatures, no matter what the temperature is, I think people are buying just about the same amount of toothpaste. I don't know. So some more examples based on the titles. What kind of scatter plot would we probably see? In other words, what kind of correlation will the two variables have? So amount of rainfall. Amount of rainfall might be just like how much it rains, like the number of inches of rain or whatever, versus the number of people attending a game outside. So I guess like every dot on the scatter plot might be a different... All right, sorry, I had to pause that for a second. So continuing on, I mean, every point, I believe this is what I was saying, every point might be like a different game throughout some kind of season, like maybe a baseball game, a Pittsburgh Pirates baseball game. So, I mean, overall, I would have to think that the more it rains, the less people would want to go. You know, like if rainfall goes up, the number of people in attendance would go down. So I don't know what's going on here, but so that would be negative. Okay, I would say that this is a negative correlation. Sorry, it's not written here. I don't know what's going on, but negative correlation. It's easy for you to say it. Amount of ice cream sold versus the temperature. So what do you think? Do you think if like at a random like Dairy Queen or something, if temperature rises, do you think there's more ice cream sold or less ice cream sold? No answer there. Well, I would think for the higher temperatures, it's more ice cream. So I think this is a positive correlation. And then, what about hot chocolate? If the temperature rises, you know, like maybe the hotter it is at a high school football game, the hotter it is, you know, wouldn't the amount of hot chocolate sold probably go down? So when this goes up, you know, this goes down. So that would be, oh, jeez, at least that one's there. So that one's a negative correlation. And, man, basically, it looks like that's it for this notes handout.